Kia ora koutou, kia ora korua to those two of you who've joined us. And welcome to tonight where Jim Critchley from Mount Maunganui College and myself, Ross Stephen from Avondale College. We're just going to take you a little bit through the geological focused Earth and Space Science standards from level 2 and 3. That is 2.3, investigate geological processes, and 3.3, dating of geological events. Kick it off with the essence karakia. Bear with me. Ki raro I te korowai kai te aki o te ketenui a tānei. Mā te hau e pupuhi te pā kahu kahu ki o mātou waka. Te kaha tānei, tangaroa, manaki tia mai a tātou katoa, I roto I te hikoitanga, I te ao o rangi rawa ko papa, hei te oranga o mātou, kia piki aki I o rawa mauri, kia toi mātou I o rawa mana, haumie huie. And if you haven't heard that before, I don't have my notes, but the translation here is beneath the protective cloak of Tane. Let it blow fresh wind into our waka, and the strength of Tane and Tangaroa, Rangi and Papa. Let them uplift us all. Let us uphold their mauri, and let us uphold their mana. Sorry, new entrance. That's prepared by Essence, and it's just a good message and karakia for us to kick things off from an earth science perspective. As I mentioned, we're ticking off the introductions. We're going to look at a few places to find resources and support produced by Essence. We'll start by unpacking the geological processes or level 2 standard, before kind of repeating the same process for the 3.3 geological dating standard. Partai, because there's so few of us, just at any point you need to either interrupt Jim or myself, or you can save your questions till the end. And following our karakia, I'd like to just bring up a whakatauki, one which I like to use to connect to geology, and that is whatungarangara te tangata toitu te whenua. So as man disappears from sight, the land remains. The key reflection or links there for me is that, geology's been here long before us, and it will be here long after us. So understanding it is going to help us, just have a much better understanding of how the world works itself. Jim, you talk us through resources.
Yeah, so as the slide says, we've got the New Zealand curriculum and NZQA sites, obviously produced by the ministry and what have you. That's got your level 1 stuff on, but the really interesting one for us at level 2 and 3 is the Essence website. So if you can just click in to the Essence website, Ross.
Yeah, it should be visible to you now.
No.
Oh dear.
Yeah. It worked earlier.
Yeah. All right. Here we go.
Sweet. So nice little plug for the astrobiology conference later on this year, but I'll talk about that at the end. So we've in the resource site. It's incredible what's on here. If you click into the level 2 ESS resources, and then into the geological processes, and then what we've got here are the different areas that teachers have done resources for this standard, and there's also exemplars as well. And so I can't see. Yeah, so if you just if you are a little bit unsure and you need some clarification straight away, then just head straight into the Essence website, go into the resources, choose the standard that you need to do. Obviously, for this one, it's the geology standard. For the level 3, it will be the dating, and just choose one of the excellence exemplars. We had a meeting in Christchurch at the start of the year. And a bunch of us sort of sat down, picked it over, And so while it's not external moderation, it has been moderated by the regional reps and a couple of the exec members as well. So you should be pretty confident that those grades are where they should be. And so that's level two. It's the same for the level three, but it really is an incredible bunch of resources that are easily accessible. You do need to be a member, and so I think on the next slide, there's the registration form for this year that Jenny Pollock has sent out. If you haven't filled it in, please do, because then you'll get access to the resources, and it means you can get help for PD, for the astrobiology conference if you need to help with funds to come up, or any other PD, and there is the potential for help from the exec.
I'll just flag too, the gym that currently membership in Essens is free for any
Oh,
teachers across the Motu. So I don't know, potential in the future for a fee to come in, but yeah, sign up while it's free and take advantage of the resources that we've got available.
yeah. And there's the YouTube where all the webinars that we're doing throughout the year going to be uploaded. So if you want to rewatch it and listen to us babble on again, yep, you can do, I guess.
Awesome. So the reason why we've like to combine these two standards into one webinar this evening is that they contain a lot of crossover between the two. So level two is mostly focused on the geological processes that form and change a particular location, whereas the level three standard is about using evidence to say when those geological processes were taking place. So you can see the two separated here, but now we've got a bit of an overlap, and this is what I like to push is the key skills that your students can gain, but also that you may need to effectively deliver these standards. So you need to have good awareness of geological processes and time, but the big crossovers for me are field skills, field trips, some good puzzle solving sort of approaches for students. And what that does is push them to that higher level of thinking required to, I guess, access some challenging geology at times. Also got to be able to unpack scientific literature and particularly at level three, use appropriate evidence to show the connections across the processes forming a particular site. One great way to find a particular site near you that could be useful is using geotrips. I mean, I've personally been accessing this for over a year. I know that I've been sharing it amongst Essens, and it's an awesome tool to actually do. So I may as well use one of the attendees as an example. So if someone there could just turn their microphone on and tell me where a location near them is, and I'll give you a bit of an explore of the website just to see what's around.
So I know there's a geo trip to Castle Rock down at Sumner, not Castle Rock, but down to Sumner to Cave Rock down there.
Awesome. Hello as well, Matt. Is that local to you, is it?
Yeah, yeah. So we use.
Awesome. So yeah, Castle Hill, I've been here myself. Amazing place, really. And you know, this is just one example of how you could use geotrips. Go to an area near you. If someone's been there before, whether they're an amateur geologist or a professional, you generally can see what's going on. Gives you all these ideas around accessibility, and like it notes this one's particularly easy. Great place to take a group of students. A quick summary on what it is, but click into it. Gives you a much greater rundown, pictures of the site, how to get there. There's links for you to click, and Google will tell you exactly where to go. It's got a what's here, a little bit of a learn about it, generally prepared by a geologist. and then have a look to give you a rundown on how it may have formed. So, yeah, really awesome tool in my opinion. And the reason why I wanted to share that with you all is, part of doing geology is being out there and experiencing it. It's fine to look in a book, but let's say if I'm in Auckland at my kura and I say, righto, students, we're doing the Southern Alps, I really can't take them there. They would really struggle to access it. So for me in the Auckland volcanic region, we go and look at the volcanoes around, and the learning we do there also supports what is part of the extreme Earth events external. The learning we do in there doubles up for volcanic-based questions that could be asked in the external. So yeah, before you go and just pick an Essence task from that drive, think, is there something closer to me that's better for me, better for my students to access? So yeah, there we go.
If it's local, it's going to be cheaper.
Yeah, true. So yeah, that you'll be able to access that link later, but I'm pretty confident it's just geotrips.org.nz. So yeah, explore that before you jump into your standards. And mahi tuatahi, the first part of our work tonight is going to be unpacking. Sorry, I'm just going to get rid of that. Is going to be unpacking the geological processes standard in level 2. Also included is the links to the exemplars, which NZQA have on their website. But please keep in mind we've got some equally moderated samples of work on the Essence Drive by a bunch of experts or expert classroom teachers that are teaching the standards.
And it's the whole essay as well. It's the whole thing rather than just snippets.
Rather than snippets, and we'll also talk about a clarification of the standard shortly too. So teaching the topic, this particular standard, often what happens or what we see with moderated work is that it's purely focused on the formation of a geological feature. And that could be a volcano, it could be a meandering river. The sky's really the limit there, but as long as there's rocks that the students can describe and talk about, then it's going to be applicable here. But as I was mentioning, we often see work that's just focused on the formation of the feature. About half of it should also be about how the feature has changed over time. So highlighting here, teach the rock cycle. If it's all about rocks and we know how those rocks formed, then you're going to be including the processes aspect of it. Also, how the rocks are broken down or moved elsewhere is going to be covering the weathering and erosional aspects of it too. Please keep in mind though, however, this is particularly true at my kura, we've got to be pitching it at level 7 of the curriculum. And a lot of our students, particularly if they've done level 1 science with no earth science involved, they're not going to have done much on the rock cycle since sort of year 9 or 10. So simply saying, it's an igneous rock isn't sufficient at this point. It's got to be a lot more detail. And the exemplars will highlight that soon too. I'd also recommend making sure there's at least 2 rock types present in the locality there. Highlighted what sites are available, and also give the students a bit of skills in order to make their own rock descriptions. There has been a question come through earlier about how much of the stuff you look for to help students with is overpitched. And you certainly see that with rock descriptions if they're just drawn down from the internet. Give them the skills in the classroom to do this by themselves is what I would recommend. And I may have already covered a few things here, but what do we mean by geological processes? It should be really specific to the feature that you're choosing. My example of the Auckland volcanic field, if I were to go to a local maunga, Maunga Keke is a good example, or One Tree Hill, and I just say, you get them to talk about subduction volcanoes. That's not really how that particular volcanic feature formed, so we'd be misleading them if we went down that route. find some evidence, find some resources that help the students know what the right geological processes are for your location, and let them do a bit of unpacking as well. EOTC, while it's extremely, well, at my school anyway, extremely hard to get it across the board and get students out there, it's the best place for them to be going to collect primary data. They can do their rock descriptions in the field. If the site allows it, then you can bring rocks back to the classroom. At the last, the last thing I would suggest for the secondary evidence side of it, you can also use Google Earth and tools like that to be exploring features, but nothing beats a day outside of the classroom with the students, even with a bit of rain for doing geology is great. So yeah, get out there if you can. Another key thing, Mātauranga, a lot of the sites that you might have local to you, they may have some, Te Ao Māori perspectives, or you may be able to find out from a local iwi, mana whanua, whoever it may be, they may have some good parako or just Mātauranga connected to your site. And while it's not an assessed part of the standard, it's just part of what we should be doing as science teachers across the country.
Certainly enriches it, doesn't it?
Yeah, it certainly does. And again, being in Auckland, plenty of iwi around. They used to have a lot of past settlements up on the maunga here. It is hard for me to find this information out, but we do get the students to highlight that Maori and European settlements are one of the drivers of change of our features that we study. So, even if it's just the name of a site that you can help unpack students with, it's going to be a pretty key thing to include there. And the key geological processes that we've got to highlight is the rock cycle, weathering and erosion, and or volcanic eruptions. So within the rock cycle, you might be thinking, oh, there's a lot of earthquakes nearby where I am. What can I go and see? Please remember, uplift is a key part of that, and that's driven by tectonic processes. So pretty much any and everything around you that contains rocks, I'm sure you can find some connection to it. And one thing Jim and I were talking about before we kicked things off tonight was if you've got something near you that's not one of our moderated standards and you want to give it a go, try and put a task together. Send it through to Jim or myself or one of your regional reps for Earth and Space Science. We'll critique it, we'll give you a bit of guidance, and we'll try and give you something that's a little bit more meaningful to your students. And before I move on from this, once again, a key highlight, split it about 50-50, 50% on how the geological feature forms, and then 50% on how that feature has changed over time. These are really just the standard statements. We're moving up to look at the exemplars for this particular standard. So just a couple of key things to highlight. At the achieved level, identify a rock that's found where you're going. Describe how the rock cycle processes form that particular rock, and then describe how erosional processes have then changed the landform you've been looking at. Sort of not highlighted anything in the merit, but then we move into excellence where we're looking at discussing, so having a much deeper understanding of those processes forming it, and then also discussing the erosional processes, how have a range of processes changed that particular site. So I'll give you an example. You could look at maybe biological weathering, biological weathering, chemical weathering, or physical weathering at a site. And then please remember, erosion is the movement of what's broken down elsewhere. That can happen easily naturally. But, if we're in this day and age where we're looking at a feature in an older geological feature, then humans can also be significantly involved in the erosion of it. Again, Auckland example, many of the maunga around, we had over 50 at one point. few of them are visible now, and humans quarrying that is a huge reason for the change in the shapes. And I wouldn't encourage my students to write too much about human influence. It might become a bit more of a geography standard otherwise, but certainly highlight if it's relevant in the area. So now we're just going to have a quick look at some of the examples. Sorry, Zara, you've got your hand raised. Got a question?
Yeah,
Fire away.
I'm really new to NCA, not ESS, just new to NCA. But I'm kind of just wondering, does the change in like the landscape, does it have to be erosional? Like if I was thinking about doing catastrophic volcanic eruption or something like that and looking at how it was before versus how it was after. So in that case, I don't want to look at the post-eruption erosion. I want to look at the eruption itself and how it changed from before to afterwards. Like thinking about 1886 Tarawera, maybe.
Yeah, I mean, certainly erosional. The volcano, blowing its head off certainly moved a lot of material elsewhere. So I would agree with you there that the actual eruption itself could look at a change in the landform. We've seen that with many of the larger volcanoes across New Zealand, where an eruption just shoots 100 meters or so off the top of it, and it would also change the landform locally. You've mentioned Tarawera. Maybe your students could even talk about the disappearance of the pink and white terraces as a result of that big eruption. It is going to change the shape, so I have full faith that that sort of task would still meet the criteria. Has that made sense to you there?
Yeah, I just wanted to check that it didn't have to be erosion because that's exactly what I was thinking. Like post eruption, obviously pink and white terraces and just sort of moving from previously silicic magma to basaltic and how that's changed even like the vent shape and stuff. So
yeah, I mean it's a great site for certainly looking at variation in rock types. And then again, I'll just read it. Erosional processes that have shaped the current landforms. If you're focused on Tarawera, I mean, I would say the whole Waimangu Valley there it is the landform itself.
yeah,
Okay?
perfect.
Yeah.
Okay, thank you so
Great,
much.
great question though. Yeah, thanks for bringing that up. Now we're going to have a little look at how we can draw out from one example that we've got some of these differences between achieved merit and excellence. So I'll just give everyone maybe 2 minutes to cast their eye over this. I won't read it to you, but then Jim and I will just give you a bit of this is why it meets that excellence criteria. All right. So I'll just this part here is purely about the formation of the rock itself. And we've got a good description of the rock it's itself above, and all I would say reading that, I know it's a student's description of an andesite. And that's what we want to see. We don't want to see, detailed percentages or splits on what mineral makes it up, because that stuff I would just say has come straight from some higher level literature. It's at a level 2 as well. It's some nice writing. Talks about the features of the rock, small coloured crystals, small air holes, and why some of that has actually happened. So if I just flick back to the standard here, maybe not yet seeing the plate tectonic processes come through, but certainly discussing how the rock is formed from a rock cycle perspective. A lot more of that comes through here. The igneous rocks are formed through ... I mean, it even starts like it's a full circle thing. Sediments heading into the ocean before being subducted at some point in time. And again, the last little part here, the student is connecting it back to the features present within the rock. Would you have anything to add to that, Jim, before I switch to the next part?
I just think on this one, it's shown you that the level, it's definitely meeting that level 2 or year 12, sorry, description. Yeah, the level of detail is good.
Yeah. And then, here's where more of that rock cycle process comes into it. Clear links to volcanic eruptions, the plate tectonic setting. So I'll just read this. In New Zealand, the Australian continental plate, ... back to the standard. We see it there in the excellence criteria, discussing the link between the tectonic processes and the rock cycle. Okay, so we felt pretty happy. This isn't the entire piece of work, but we felt pretty happy that at the excellence level they were discussing how the rocks had formed. And then this here moves on to talk about the change in the feature over time. It's also brought in other rocks too. And what do we have here? Starting to talk about mechanical weathering ideas through water and through abrasion with the water. And later on here, as the notch grows, the top part of the cliff overhangs or breaks off. That there is starting to discuss how the landforms are changing over time. Jim, anything else on that particular?
So they were all taken from sort of different pieces of work. So they're obviously all not just one piece that's jumping all over the place from different localities. So they're all taken from separate students' work.
Yeah. So this one here, the Otoko Beach, clearly just the last part with the undercutting cliffs. But yeah, as it points out here, it's not the whole assessment, but you can easily access that through the drive there.
This was a clarification.
Straight from the clarifications. And I think I'll read the whole thing. But the locality can be anywhere in New Zealand, the Cook Islands or Niue. And given that, Zealandia, the continental landmass of New Zealand, all of those exist. All of those 3 locations listed are part of Zealandia, essentially. We can kind of then look at basically anywhere on that continental shelf. The processes must reflect current geological knowledge, so that's why we've got to have a bit of a browse in advance at what's available out there to us. And there's an example about Takaka marble presented there too. That would be limestone formation. So we've had a few recommendations as part of the ramp process, or a bit of a review of level 2 ones. So do just watch the space or any documentation coming out around the standard. Essens as a subject committee's had a few ideas of things we'd like to see a little bit different. I won't say too much more about them now, but yeah, keep your eyes peeled on any changes coming up. Jim, do you just want to give a quick chat about what things are available there?
Yeah, so that list there is everything that's on the website for the resources, and each one of them will have your has been moderated by the Essens sort of committee. And I think, like Ross spoke about it earlier, that try local first. Please contact us if you need advice. So the other day I got a question I couldn't answer, so I passed it on to Najeen, and within a day it was all sorted. So if one of us doesn't know something, we've got access to everyone around the country. So if you do have an area that you want to study, and we can't help you, promise you someone will do in the exec or the regional rep. So
and thanks for raising that, Jim, because I thought I should just bring up, if you don't know who your regional rep is, also on the Essens website we've got a list of who the best person for your local area is to reach out. Some regional reps double up across a range of areas, and that's just to particularly where there's a lot of kura just to make sure we've got enough coverage and enough people out there to support. But yeah,
Actually, Erin, I don't know if anyone knows Erin Nolan. She needs to be added onto that list as well. Erin is a geology nut as well. She absolutely loves rocks. She's incredibly knowledgeable. And so she would be one of the go-tos for any geology questions as well that we can't answer.
and sorry, Jim, can you just clarify which area Erin is associated
So
with? Is it
she's based
Wellington?
in Whakatane.
Okay,
So we're sort of sharing Waikato and Bay of Plenty, Central North Island, Coromandel.
okay, great, awesome. Thanks for that clarification. But yeah, you can find info on heaps of info on the Essence website as well too. Yeah.
Yeah. And that's where your geotrips comes in as well with the local. Yeah.
Um, Team, we're about to move on to look at the level 3 standard. Before we do so, has anyone got any burning questions about the level 2?
Sorry, could I please just ask a question about that exemplar that you had with the andesite? I might have missed it because it went pretty quick. Do they just have to talk about the plate tectonic setting? Like they just have to say it's subduction? Do they have to say how subduction zone magmas were actually formed to produce the andesite, or just the tectonic setting and that it's subduction?
Are you talking about the particular slide I've got up now, Zara?
Yeah. Do they have to talk that it's like flux melting, like, from like water coming off the slab or anything like that? Have to talk about that? I can just say the word subduction and it's tectonic setting and it's all good.
With this one, I'll just highlight, it seems like a throwaway comment here, but, please remember these aren't the full bit of the student work.
Oh, yeah,
Um,
sure.
yeah, but, in terms of flux melting and things like that, that's pretty challenging stuff. Do you, by chance, teach the extreme Earth events external?
I haven't taught any NCA.
Okay. Then, with it, I'd say we're sort of pitched it on the same level as what's in that external. And students
Okay.
have to be able to describe it's basalt, andesite, and rhyolite, the features
Mhm.
of those. And they just have to add ideas about how they become different magma bodies. So you
Okay.
mentioned before sediment inclusion. At the excellence level, I'd hope a student says, the subduction zone drags fluids and sediments in, which can change the viscosity or silica content of a magma. That's what we'd like at an excellence level. Would you agree, Jim?
Yeah, definitely.
Yeah.
Yeah.
As far as like partial melting and that I'd say is a little beyond is sort of level 2. And I know from conversations with university lecturers, they often sort of query why students might come in with ideas around that already. They think we might overpitch it at the level 2 and 3 standards. So, yeah, we often do get caught up with, I guess, a bit of what would you call it? Academic creep might be the thing.
Mm.
Yeah,
Mm. Sure. Yeah. Thanks so much.
no problem. Um, so yeah, Mahi Tuarua, starting to look at the level 3 standard. And yeah, I pointed out earlier the key difference is that we now got to be using evidence to talk about how a feature has formed. So same again, you got the clarifications linked in the NZQA exemplars, and we'll show you a range of tasks that have been moderated by Essence too. So explanatory notes there. I do want to point out the achieved part up the top here, investigate involves. Please note at level 3, we're no longer just saying describing geological events. We've moved up to explain, so we want the students, being able to give good scientific background on how a geological event has occurred. And an example, not just saying a meteorite hit Earth. How did the meteorite enter Earth's atmosphere, and what happened to it before it hit Earth? That would be a good example of an explanation for a geological event. And then the other achieved criteria explain a range of evidence. You can't just say one line of evidence. We're looking at 2 or more bits of evidence to help contribute towards the dating of the event. And you can see at the bottom here in the slightly different text, I've taken from the standard what lines of evidence could be considered appropriate. And a wide range of them. I think stratigraphic principles are probably pretty key anywhere because you've got sedimentary rocks all over the show. And if possible, if you're looking at volcanic features, there's likely to be some form of radiometric date out there as well. Other things which would be very locational specific, looking at dendrochronology or tree ring data. Sediment cores, pretty hard to get hold of, but if you're close to a university, they may have a lot of photos they could share with you, and at times they may even be prepared to bring a sediment core out to you. I'd really like to put some sediment cores through my field out here at my school and see what's happened, but I know our cricket team certainly wouldn't be keen on that. But have a look around at what's local. Your universities may have stuff to share with you. And fossils and fossil succession, going to be pretty hard to find at a wide range of sites. So that's more likely to be where some literature, you draw down information from literature to support your students. Things to think about when choosing, looking at what a geological event is. And, the key thing about this is it's not restricted to New Zealand. You can look worldwide, and we've sort of started to explore as a subject committee, using geology to date events elsewhere in the solar system, because that's still local to Earth. So, geological features or impact craters on the moon, and potentially even looking at, the theorized tectonic movement on early Mars.
Sorry. So just on that with the Mars and the moon, I have checked and there is information online. Then they have done at least 2 dating techniques for moon and Mars rock, and just recently on Mars, they've actually done some more testing. The rovers have done it and sent that data back. So they do both meet the criteria for the standard.
Yeah, and that's awesome that we can sort of extend to the wider solar system, because at times I know there's a lot of schools where they do Earth and space science, but sometimes steer away from the more challenging space standards. This is a good way to include it and give your students a bit more to think about rather than going and looking at a local rock. But pretty hard to take a field trip out to anywhere beyond New Zealand, I'd say.
Well, hey, there's no harm in looking at overseas trips.
Yeah, that's true. Yeah, it might be a 2 years down the track thing and extensive fundraising. But if you want to get away,
it's
look
doable
somewhere. Yeah. And Jim, you've been on a overseas field trip recently, have you?
Yep. Last year we went to Maui in LA.
Oh, awesome.
And had a bit of a space focus there. So hence that's why I just said, the dream big, to go local for level 2 and international for level 3.
Yeah. So fewer students often take your level 3 course too, so a little bit more manageable for a much bigger scale field trip.
Yeah.
And I've already mentioned this in the level 2 standard coverage, EOTC, what's around you, what can you go and look at, and is it accessible for you and your kura. Now just flick back to the this part here. I want to focus on the excellence criteria, so investigate comprehensively. You'll notice the second bullet point says cross correlation, so just want to have a bit of a cordial around that. And the things I thought are key when deciding what to do is have a think about, does the site you want to go to, does it have more than just stratigraphy? Are there fossils present? Is there something else around that you can allow your students to look at more than one line of evidence? because if it's just one, then we're not going to be at the excellence level. Well, it'll be hard to argue um, giving a student excellence when they've only talked about one dating technique.
Yeah.
So cross correlation, you've got to have multiple things to talk about. Okay.
Yeah.
So yeah, a few examples of geological events. I wouldn't say we've got all of these on the Essence Drive. Happy to brainstorm a few more if required, but we thought volcanic eruptions, nice, easy one. You often have stratigraphy and radiometric ages. Sometimes you may even have witness statements to help talk about that particular event as well. Mountain building, you certainly wouldn't. That can take millions of years, but heaps of evidence around mountain building events. We've got the South Island here, but other examples worldwide. The Himalayas is perfect for that sort of thing. And, I certainly haven't been to the peak of Everest, but I've heard there's limestones present up there as well. Sorry, I've got a late entry to the office. Hi. Excuse me a second, team. Hello.
Oh, sorry.
Oh, it's all right. You're just in there?
Yeah.
Yeah, that's okay. I'm on a call. Thanks. So yeah, other ones, historic earthquakes. I know in the Wellington region, there's certainly a lot of river terraces and uplifting going on, that can be explored. Meteorite impacts, not so many of them around New Zealand, but there's always the dinosaur impact. And I might bring up quickly in the background too, geotrips, because a couple of weeks ago I walked across the KT boundary in New Zealand. Now the KPG boundary. I'll just show you briefly where that was too. Continental breakup, seafloor spreading, ice ages, mass extinctions, coastal erosion. We've all considered those as great examples of geological events. So before I forget, just going to go back to geotrips because I had no idea it was present in New Zealand. But the reason why I went to this particular site, it's quite far out the way, is I found it on geotrips and just exploring. Much, much smaller features than the Modaki boulders further south in Oamaru. But then I found this here, and the KPG boundary at the Chancet Rocks. It was a pretty wild beach. There was not another soul there on the day. About an hour walk from the car park, I came across it. And sorry, that's just trace fossils. But yeah, you can clearly see here the KPG boundary. Pretty hard for me to identify, but I believe it here when it says, the rocks have been tested and they've got 10 times the amount of iridium than usual. So fascinating for me to get there, but I'm not going to take my students to the South Island this year. So have a good look around and see, do we have evidence near our school that might link to some of these? Continental breakup would be hard, but you'll certainly have coastal erosion features, and volcanoes or earthquakes nearby. Jim, do you want to talk briefly about your impact on the moon, because this is a task that you're looking at?
So with this one, with the I can't click onto that. Will clicking on that dating rocks on Mars take you to the document?
It should do. Hang on. I'll load it up in the background for you.
Oh yeah. And so not having a geology background myself, if you so just scroll to the top. And so one of the professors in Auckland mentioned she'd done some work with JPL on the geology of Mars. And so she gave me this link, and I think you can see there 2013 is when they did their first rock dating experiment on Mars. And so after having a chat with Ludmilla, that sort of got me thinking about the level 3 standard, and could we go outside of Earth? And so it sort of set the ball rolling a little bit. I developed a task initially with AI, and then I think we're just sort of in the process of developing that a little bit more. I know, Ross, you talked to Najeen and Justin about it as well, and
Yeah.
Justin's done some more work on a standard. And so again, just sort of watch out for any notices when we put some new stuff up with new CoPAPA, it'll all come up on the Essence website.
Yeah, and awesome, Jim. I hadn't read this, but you can see. I don't know why it's
Yeah.
highlighted, but potassium
I
argon
think
dating.
I highlighted that. I think.
Oh, wonderful. I mean, we use that as one of our lines of evidence for the feature we study, which is a West Coast volcanic eruption roughly 20 million years ago. So there's pretty good data out there for a wide range of volcanoes. A lot of them are done using potassium argon dating. And I guess the benefit is rather than, you have to state the age as a student to achieve this. But, you don't have to go and teach them radioactive decay to the fullest extent. It's about using the evidence. So a student might just put together a quick, there's potassium in rocks, which can decay to argon over time. So measuring the ratio of them gives us this particular age and helps us cross-correlate evidence. It's not a step-by-step on radioactive decay, which is beneficial. I'm pretty sure I've at least talked to most of this already, but geological time was something I brought up early on in the piece. I always like to introduce my 91412 standard by spending a bit of time by spending a few lessons looking at deep time with my students. We go back as far as, the formation of Earth itself and looking at some key events, great oxygenation event, like pretty high level stuff, but it certainly engages the students and brings them into, geology at the higher level. I also make a real focus on stratigraphy. If you don't have sites nearby, it can be as little as interpreting some geological puzzles. Students really get behind that. It's quite accessible. There's also often never a true answer. So whatever the students come up with, you can sort of tell Toko what they've come up with and just give them encouragement. Say, you know what, you're doing a good job. I always like to suggest too that geologists spend a lot of their time arguing with each other over who's right and who's wrong. So even getting it wrong is not a big problem at this stage.
Mm.
Field geology and observation skills, they're things we want our students to do a better job of just in general, being better observational, scientists. And a big one, research and processing information. I did have a question in advance about it often being a bit too highbrow or at the doctorate level. So I just want to highlight that, a lot of what you're going to present to the students is going to be beyond their capabilities, but just let's remember selecting and processing is a key skill across any level 3 Earth and space science standard. So if you do need to spend a couple of lessons unpacking materials for them or teaching them how to trim things back by half and put it in their own words, then it's going to be beneficial for the year ahead anyway.
Yep.
The assessment tasks that we've got around, we've got the Alpine Fault, so earthquake would be the geological event or mountain building there. Heaps of evidence for the timing of that scattered throughout literature in New Zealand. Auckland Volcanic Field, there's a whole team of PhD students in Auckland that part of Devora, looking at volcanic risk in the region. Their whole study is going volcano by volcano and seeing if we can improve what we know about them. So there's also tons of radiometric ages there. Dunedin Volcanics, similar type of approach, but a lot older than the volcanic field. I know Justin Zaney down in Dunedin, that's a focus for his students.
Yep.
You got Whakaari White Island, geological event was pretty recent there, but it's been erupting for a long period of time. Topor volcanic zone, if you want to look at catastrophic events, then that's a great example. And there's even evidence offshore of its eruption. If you weren't aware, apparently ash layers that share the same chemistry to the Topor eruption, they're present in Japan. So looking far and wide at where the evidence can come from. Jim, do you teach the standard in Mount Maunganui College?
No, we don't, but we're looking at doing that this year. If we can develop the Mars one in time.
Yeah, and I mean the only reason I raise that, you've got Mal right down the road, or Mount Maunganui. Most of your students have probably been there. It's quite the significant feature in the area, but also you've got some pretty big craters nearby as well, which have some of that sedimentology or stratigraphic evidence present there too. So
that's actually a good example, sort of having Moal, because there's not actually a lot of data online that's accessible. So we're probably not going to offer Moal, even though it's so iconic for us. But we are looking at the not just the Mars one, but also Kaimai's.
Oh yeah, I mean, same sort of idea. I mean, if you even just mentioning that, Jim, I'd sort of flag, you don't have to you can go to a site with your students and do geology, but you don't have to make that the focus of your actual assessment if it's too challenging. It'd be great if they marry up, but a visit to Moau just to explore what a dacite dome might look like, but then your assessment you could maybe shift it to somewhere, maybe I forget the true name, Makoia Island, there in the middle of Lake Rotorua. That's the same sort of geological feature, but it will have a bit more supporting research around it. So yeah, do definitely just try and get your kids out doing some geology. I'll point out real quick, team, because we're nearing 8 p.m. But this here, it's starting to look at a few different examples of where things can be used to date a Topor eruption. So you've got sulfate levels, pretty challenging stuff to look at, but trapped in the ice cores. You might have to talk about ice formation and how it traps gases and aerosols present. But if it's quite a great line of evidence to give you 180 years plus or minus 10 years. That looks pretty accurate to me. But then you can see in the second chunk here, they've even used a statement cross correlation. They've brought in how carbon dating could be useful. And that's two different lines of evidence to support dating.
And just one of the things we talked around that in Christchurch at the start of the year is they have to choose relevant dating techniques. They can't sort of explain carbon dating for a process that would never be used for that geological event. So it does have to be relevant.
Yeah, great point there. Yeah, like you're not going to talk about carbon dating for uplift of the Southern Alps. Carbon dating's really only good to about 50,000 years. And when you're talking about something, potentially 10 to 20 million years ago, you'd if that were included in the final piece of work, you'd pretty much just have to strike a pen through it and ignore that part.
Yeah.
Yeah, and that is one of the clarifications too, I believe, Jim. Supported by relevant info. I'll get to that shortly. So here's another example, radiometric dating. They've mentioned two, but then they've only given one of the radiometric dating ages. I'd say they come out to pretty similar. Excuse me. And that's for the Dunedin volcano task. Certainly a lot more of it present in the exemplar that you can access through the drive. So here's that clarification. And just wanted to point out again, you've got to have at least two dating methods. A well-designed task might give, well, if available, might give students four key pieces of evidence they could talk about, and that's just there to sort of help. If they under-explain one or more lines of evidence, they could still potentially get into that excellence criteria. And yeah, as Jim pointed out, the dating method must link to this the event being studied. Anything you want to add on that clarification there, Jim?
And I think it says, I mean, I know it says New Zealand or worldwide, but we're pretty confident the Moon and the Mars meets the criteria for the level 3 standard.
Yeah, and that's certainly already gone to NZQA as one of our recommendations to expand it to beyond, to make sure Earth and space are part of the standards available to our students.
Yeah.
I'll follow up emailing out these slides, team. But yeah, they've got all the links available in them. Please keep in mind that if you're not a member for Essence, you're probably going to get no permissions to access this at the moment. But you'll certainly be able to sign up for free and have a look. Matt, I can see you've got your hand up. Shoot away with your question.
Yeah, so not so much a question as a comment, actually. So on the last thing I said on one of the last meetings, I am based at the University of Canterbury in the geology department for the 6 months doing the science teaching leadership program.
Oh, awesome.
And first of all, a plea from the geology department, particularly in terms of what they're saying with their first years coming in. I think Kate would be absolutely overjoyed to hear you emphasizing the stratigraphy.
Yeah.
Because that's such a huge part of what they do. And she's like, her feedback is that the students that they're getting, they might have done a bit of radio dating, they might have talked about carbon dating, but she's like, you've got to teach them stratigraphy and the interrelationships. So really cool to hear you say that. Also, like, she's really keen to emphasize trying to get the kids seeing a range of different methods. And so one of the things that we're trying to do just over the next sort of month or two while I'm still there is see if we can develop a couple more assessment sort of topics for the level 3. Because yeah, she's really keen to support us to get some more resources available.
Matt, could I ask, could you have a chat with her? Because obviously hearing that is awesome for us.
Mm-hmm.
If she wanted to put a little sort of blurb together, then that's something that we can sort of show the exec and then get out to all the members as well about what the unis are wanting.
Mm-hmm. Yeah, definitely. And I guess the other thing I was just going to share, because it's not on any of certainly the standards and stuff, the shiny new tool in the toolkit. There's a lot of interest at uni at the moment with cosmogenic dating, which is basically looking at how cosmic rays, once rocks get to the surface, the cosmic rays start to generate radioisotopes. And so they're now using that to date when rocks have been brought to the surface. So there's not a lot of information out there yet, but it's kind of cool, just in one of those, like I say, shiny new toy that the geologists are all quite excited about.
Yeah, that's awesome. I like what the future holds for this subject if it remains strong in the revised curriculum. But yeah, cheers for raising that. I might ask too, Matt. Yeah, I've taken some notes about your pointers on stratigraphy, but Jim and I will shamelessly ask for some feedback through a link. Could you just make sure you reiterate those comments about stratigraphy?
Yeah.
Awesome. And yeah, maybe another time. Really keen to hear about your experience on the science leadership program. Yeah, awesome that you're involved with that. Really cool.
It's a very cool program.
Awesome. Yeah. So yeah. Any other partai from those attending, either level 2, level 3, or just general geology before we look at wrapping it up?
If there's no questions, Ross, could you just flick to the Essence website for me?
Yeah, sure.
And could you just go to the conference? So I think obviously that there's a few of you that were on the last call that I did with Justin as well. So we've now finalised it. So hopefully you've got an email from Justin with all the details. I think we the exec are looking to help with funding for this for those that are outside the Bay of Plenty. And so if you are interested in a couple of days on astrobiology, we've got the costs right down to $110, and that's because the New Zealand Astrobiology Network have got the funding for the overseas guests, and so that the cost is essentially the trip to Waimangu, the entry into the Waimangu volcanic site, and then the food for the second day when we're hosting it at Mount College. So yeah, if you're keen and you know any other teachers that are keen, then fill out the registration form and ask for help for funding. I can't remember if it's $500 or $750, but yeah, it should go a significant way towards helping people from around the country.
Yeah, I know that often with the funding that Essence has available, a lot more of it's directed to those in rural schools or those that are just a lone teacher in a school of Earth and Space Science. We look to support those a little more than just, I personally wouldn't get, if I wasn't connected to Essence, I wouldn't be getting any funding because I'm from Auckland at a big school with lots of support, if that makes sense. But yeah, looks fabulous. So, oh, sorry. So, yeah, any other question? I feel I covered that one. But any other questions? All right. So, yeah, I'll include this in the email with the slides too. Part of putting these events on, we've got a report to TDA, Teacher Development Aotearoa, and the network of expertise on the effectiveness of the evening. So, I will follow up in a couple of days, but I ask those that have been attending, please fill this in for us. It's not extensive, but just leave your email, which session you were in, and I guess from my perspective, how we might have helped your pedagogical approach to teaching these standards, or what some of the highlights or further comments you might have are. Particularly if you want some follow up, leave those statements, and as a subject committee, we can look at getting back to you.
And all the feedback does sort of go back to Nex, who helped fund this as well.
Yeah. So without further ado, team, I'll give karakia whakamutunga or an ending karakia, and then I'll stop the recording. If you've got something more informal to ask us, then don't be shy at the end. But ka whakairia te tapu, kia wātea ai te ara, kia tūriki whakataha ai, kia tūriki whakataha ai. Haumie, hui e, tai iki e. I really like that one. Restrictions are moved aside, and get on back to your lives and enjoy what little of the night is left. And just from Jim and I, a real big thank you for joining us and engaging in tonight. Spread the word. We've got quite a lot more webinars coming up soon, which cover all of the Earth and Space Science standards. I will highlight that's quite connected to this one. I think in week 5 of this term, myself and John Smith, if you know him, we're going to be running through how field trips should be run, and it's a good kōrero alongside what we've talked about today, which is just getting out there and experiencing geology. So thanks very much for joining us. I'm going to stop the recording and have a lovely evening.